Hello and welcome to our session Reliability Refined Welded Plate Heat Exchanger to Enhance Efficiency. My name is Alexander Stotz and I'm working for more than 10 years with CHEVRON, responsible in the field of process applications. Thank you for joining the session, and I hope that we can discover together in the next 15 minutes how welded plate heat exchangers can exploit energy saving opportunities and contribute to reliable operations. During this presentation, you can at any time post your questions in the panel and we'll try to answer those questions right away. So let's start with this presentation. Consumption of energy represents a significant contributor to emissions and to the overall cost of an industrial process operation. Pushing the operations more towards an environmentally friendly and sustainable direction may be achieved in many shades of green. CHEVRON's multidimensional portfolio of heat exchanger solutions will support individual solutions to reach a greener future, shade by shade. The green shades of heat exchangers are given by their intended purpose: exchange heat. Reduce energy consumption is one of the main targets, together with lowering the carbon footprint. Selecting the right type of heat exchanger with a smart and sustainable design is a key factor. In the end, the thermal efficiency reduces emissions and will go at the same time hand in hand with remarkable energy savings. A focus on operational reliability makes the industrial process more stable and enhances the lifetime of the process and of the equipment itself. Efficient and reliable welded plate heat exchangers, such as the K-BLOC, which we will feature in this session, are extremely powerful to increase the heat recovery from existing processes. How this is achieved, we will demonstrate in the next following slides. The K-BLOC is, due to its compact and strong design, a leading equipment for the process industry in terms of heat recovery. The K-BLOC can be used in applications up to 400 degrees Celsius and a maximum design pressure of up to 50 bars. It is used in liquid-liquid applications as well as for condensers, evaporators and reboilers. The K-BLOC is a fully welded PG without any elastomeric gaskets, and it is openable from all four sides. All gaps and areas of the heat exchanger internals are accessible by dismantling the panels. Also, 100% of the welds are inspectable and, even if needed, repairable. The initially promoted efficiency of the K-BLOC is based on the plate geometry, which is the main enabler for the outstanding heat transfer. The K-BLOC comes with the standard and high-performing CHEVRON corrugation with increased turbulence. A higher grade of turbulence is beneficial for heat transfer and also for the so-called self-cleaning effect. The second corrugation type is the double dimple. It performs with slightly lower heat transfer coefficients but is capable of handling solids and small fibers. Also, where small pressure drops are only permissible, such as small vacuum condensers for instance, the double dimple offers advantages over other corrugation types. And an even more easier cleanability because of the continuous gap is an additional pro for the double dimple corrugation. The core feature of the K-BLOC is the plate pack. All previously described advantages are originated from the plate pack. So, the reliability is created here and special attention on design and manufacturing was assigned to this step. The K-BLOC comes with a strong and robust corner design to transfer reliably regular operational stress from the plate pack to the pressure-carrying parts. A pre-compressed plate pack is crucial to ensure solid metal-to-metal contact of each plate. The comp is, together with the corner design, the most important feature for the stability. The 3 mm comp is welded to the plate pack and to the column liner without any weakening cold-forming steps. High-quality filler material parts are used for those welds. Now, after we have discovered some technical features of the K-BLOC, we want to go into 3 case studies in order to understand where the shades of green are getting visible. The first case study is for a condenser. It is a heat recovery application where the highest possible degree of heat recovery was one of the targets, next to the actual purpose, the separation of water from overhead vapors. For the design, a temperature cross had to be considered. The solution is a K-BLOC in a robust and compact design. To achieve the process parameters of 1.1 MW, duty with a 6 to 7 degrees temperature approach, with temperature cross at the same time, it was necessary to design the unit as a vertical multipass condenser. It has now round about 80 square meters of heat transfer area. In this picture we can see the condenser covered by an insulation next to the column. To point out the operating conditions, we have demonstrated those in the table. In this stream are water and CO2 present. The operating temperatures show the tight temperature approach and the temperature cross as well. A shell and tube design would have resulted in a 2-unit serial design with a higher weight and higher volume of the equipment. So, how is this compact design possible in a welded plate heat exchanger? The heat transfer takes place in the gap between two heat transfer plates. Here we can find, due to the geometry, a high turbulence which promotes proper and good heat transfer, meaning it results in higher heat transfer coefficients or so-called K values. The turbulent flow also creates a self-cleaning effect and reduces the fouling tendency, which leads in the end to longer service intervals of the heat exchanger. This can be expressed with the so-called shear stress, which is 3 to 10 times higher than in conventional shell and tube heat exchangers. K-block heat exchangers are using the cross-counterflow principle. This is extremely beneficial for interchangers in heat recovery applications. This and the turbulent flow enables the K-block to achieve temperature crosses within 1 unit. A closest possible temperature approach is between 5 to 10 degrees in process applications possible, but it varies of course depending on the specific application. All this leads to the conclusion that the K-block is a very powerful interchanger. To underline this, we will go back to the recent condenser case. The saved energy of approximately 1.1 megawatt can be converted into a saving of round about 1.5 million kilograms of reduced CO2 emissions. Based for this is the reduction of burnt natural gas in equivalent in 1 year with a continuous operation. Generally, heat recovery applications using K-block as an interchanger are important, as every single saved kilowatt of energy pays out in lower operational expenditures and, of course, a smaller footprint, CO2 footprint as well. This leads us to our second case example from a Western European refinery. The K-block is an addition to a new pre-flash column which was required due to the feedstock changes in the refinery. The feedstock change took place after the 2017 revamp. 2 K-block BT120 units with nickel-based alloy C276 plate material are working in parallel now. The customer chose higher grade material for K-block because of higher corrosion resistance at lower Capex compared to shell and tube. This was the best balance between low Capex, high efficiency and no corrosion risk. In this application, overheads from the pre-flash column are used to preheat the crude oil. Again, this is a high-duty heat recovery application for the block. And did you know, an interchanger that mainly is used to avoid the usage of primary energy also has another important and valid advantage nowadays. Every single recovered kilowatt reduces the amount of cooling as well. This results in lower power consumption for air cooler fans, for example, or in the reduction of cooling water. Periods of low rainfall bear the risk that rivers may have too high temperature to cool properly, or the volume is too low to cool down as required. This makes additional air coolers or cooling towers necessary to avoid turndowns or even shutdowns of production. But let's go back to our case studies. This is the third one. It is a new investment from a vacuum gas oil hydrotreating unit. In the background of the project, capex and space constraints for conventional technologies were governing the decision. Of course, the target was the high heat integration requirement to reduce the energy consumption. The conventional solution offered 5 shell and tubes in series, but the K-block provides a unique solution. 1 K-block is able to perform instead of 5 shell and tube units in series. The K-block achieves the same heat recovery, but with lower capex and a lower footprint. In addition, the K-block has a much lower pressure drop, which reduces energy consumption on pumps. 1 bar or less with the block versus 2.5 bars for the shell and tubes. So, as a summary, the total investment costs for the new plant could be kept at a lower level, and the K-block provides the operational reliability for a long lifetime. In the beginning, we have said that the operational reliability is important for any process equipment. The K-block can reduce, due to its plate design, fouling, which is the main threat for service interruptions. The high shear stress, which we always consider in our designs, reduces the fouling tendency. After a while, Fouling will occur anyway, but then the K-block offers the possibility to clean the plate pack entirely by mechanical means, for example by hydroblasting. But also chemical cleaning is always a good option. While the heat exchanger is open for cleaning, a thorough inspection for corrosion or blocking solids can be done as well. Keep in mind that all welds are inspectable, accessible, and repairable at this stage. As we have seen, the shades of green with K-block are comprehensive, and the targets of energy savings, reduced emissions, and reliable operations are tailored to the K-block. The thermal efficiency of welded plate heat exchangers achieve these shades of green already now and is very well established in the process industry. So, with that, thank you very much for joining our session. We are of course available for further discussions and are looking forward to receive your questions and feedback. Thank you and goodbye.